I had this 10-year-old laptop, Samsung i7 second generation computer that was slow. I didn't notice it was slowing down until I started video editing, and then I realized how long it took to edit videos and export the videos through Filmora 9. And I realized that something is wrong with my computer, and I opened up the back and checked it, and I found that the fan was a bit dusty, so it must be the CPU temperature was going up. And so I looked at monitoring the CPU temperature, a few programs that you can use. But when you run it with Cinebench R20, Cinebench drops the speed of the computer. So I decided that I run it without these temperature monitoring programs. And then I found out that I could almost double the speed of my computer, and tested out some novel cooling techniques, which I will mention later. I was running the laptop without any cooling, and I was checking the CPU temperature, and then the computer crashed when it hit about 97 to 100 degrees C, 100 degrees C I think, and then it blanked out, crashed completely. So there is a safety system designed into the computer to prevent it from catching on fire. I spent about half an hour cooling the computer with a table fan before I could switch it on again. That was when I noticed that 10 years of dust had accumulated on the CPU's cooling fan. And the next day I took my laptop in for repair to clean the whole computer, because I didn't know how to open up the inner parts of the motherboard and all that. Those guys were really great. They really helped me out. The CPU heatsink paste was broken and crumbling. This is the view of the component side of the motherboard. The CPU was taken out. There, can you see how much old gunk is on the CPU? The grey paste. He just turned it over to show you the pins. It's so important to have the CPU and the video chip cleaned and recoated with a fresh amount of heatsink paste. And then also on the heatsink side of it, and also on the copper side where the heat extraction takes place with the cooling fan, that too has to be cleaned up.
துணி எடுத்துதா ஏதாச்சும் ஒரு துணி எடு ஆமா ஒரு யூடியூபர்
Let me give you a word of advice. Don't try and do the cleaning yourself. Hand it over to the experts who know how to dismantle the laptop and put it back together properly without damaging any of the parts. And they have the correct chemicals for cleaning and refurbishing the laptop. What I have to let you know is that before cleaning the machine in the shop, I did a Cinebench test and it came out to be around 500. After cleaning and reassembling the laptop, reran the Cinebench test again and the results were, I think, if I remember correctly, 745. That is a huge improvement in performance. But remember, this is running under air-con condition. I checked the temperature later. I brought my thermometer to measure the temperature, and it was 26 degrees centigrade in the air-con shopping mall. At home, when I run the Cinebench test, the room temperature, because my house is not air conditioned, the house temperature is 32 degrees centigrade. So you can imagine how much of a difference in speed there is at room temperature and after air conditioning. Actually, I must let you know my test results before cleaning at room temperature was around 400. It was dropping to 380, between 380 and 444. Running in an aircon environment makes a big difference to the performance of the laptop. As you can see, I tried many ways to cool my laptop. I pried open the keyboard, upper side of the keyboard, to reveal the motherboard, the solder side of the motherboard, and blew in air from a table fan. The air temperature was 32 degrees centigrade. So whatever cooling I achieved was because of the airflow clearing the hot tracks on the motherboard. I ran many experiments over the next few days. Some I had airflow from the right, some airflow from the left, some from the front, and I opened up the keyboard and exposed the right of the keyboard, the left of the keyboard, and sometimes I found that the airflow is critical. When in some directions the speed, Cinebench speed, drops to 4 to 8. Some directions it moves up to 7 to 1. There's a huge variation, and then I realized that cooling, there may be some turbulences or hot spots within the motherboard that was causing these problems. I tested the improved performance of my laptop by using Filmora 9 to export a 1.5 gigabyte file. Before improving the performance, it took 4371 seconds to export the file, and now it takes 2226 seconds. That means my laptop is twice as fast with the cooling fans. Room temperature is 32 degrees centigrade. The next day I tested the speed of the unit and came out 539. Okay, now I'm running it with my D drive taken out, so there's a big hole here on the side. This experiment showed that there is something not quite right about the airflow in my laptop, because the computer was faster. 588, much faster. What I like to see as an improvement to laptop design, the triangular shaped laptop, because currently this is a spoiled base plate for a cooler fan, and I got fed up of replacing the fans every 3 months, so I decided, forget it, I will keep my this triangular based base plate so that I can have a tilted laptop, right? So it's easier for me to type. and that I think is will be a good improvement for many people. So from the experiments, it looks like there can be improvement to the laptop CPU cooling by modifying the laptop design, having, let's say, a double-decker design with a, for example, here, let me show you my cardboard cutout. So here we have the keyboard on top. Okay, it will be much slimmer than this. I'm just showing you an example. The keyboard is on top, and then there is maybe half a centimeter or 1 centimeter of additional double-decker space. Okay, so that the air can go in. There is a big space cut out here to allow cool air, room temperature air to go in. We're talking about room temperature cooling, right? We're not talking about air conditioned cooling. So this allows the room temperature to go in, and probably some exhaust fans, because it is higher up. You can have space for exhaust fans at the back, and you can also have plenty of additional USB ports and other ports and jacks and mini jacks and all that, so that it almost behaves like the performance of a desktop, right? Desktops have 4, 5, 6 USB ports, and you can have on this side and this side, and you can have external hard disk drives, additional drives, and that will really improve the performance of laptops, right? And the cooling, because you have additional air gap, you get better cooling, right? And this is what I think would be the next stage in laptop design. I would think that's this important, especially for people like me. We are developers. We spend all our time at the table. We don't carry our laptops around. And if it's just a little bit higher, you still can pack the laptop and take it from house to office and office to house, right? So this is what I suggest that maybe laptop manufacturers should consider to improve the speed. At the moment, their speed is limited because they are unable to have better cooling for the CPU to allow the computer to run at a higher speed. With a big hole on the side, the computer ran 9% faster. When a slow fan blew into the hole, the laptop was 15% faster. When I speeded up the fan, the laptop slowed down. Many years ago, I discovered that when I was using the AD590 to measure oven temperature, by exposing the leads of the AD590, I could get a better accurate temperature reading. Okay, this is a circuit that I designed, I think more than 10 years ago. It's my car air condition controller, because it was giving so much problems that I decided to throw away the existing standard circuit and design my own. And what I want to show you is, from the test circuit I ran with the AD590 34 years ago, I found out that if we cool the leads, the die inside will come to a lower temperature also, because the supply and the ground lines circuit from the leads go right across all over the die. So even if you just use the VCC and VSS to cool the die, that should be quite effective. So what I was trying to propose was that if we had some form of cooling on the leads, right, then the die temperature should drop, because the leads are connected directly to the die, and for example the 5 volt, here in this case 5 volt and ground, or VCC and VSS, they will be going all over the place, all over the die. So every part of the die will access the lead temperature drop from cooling on the VCC and VSS leads. Now for example, we could have put a either here on top or at the bottom an array of fins, right? An array of fins that attach to every lead, right? And as the air blows on the fins, it cools the die internally and brings the temperature down. So I would have thought this would have been a more effective way of cooling the CPU die instead of trying to cool it through the package insulation. And that was the reason why when you look at the motherboard, I was blowing air on the motherboard, because if I cool down the motherboard, all the leads from the CPU and all the other devices are going into the motherboard and will get cooled. So the cooling effect is conducted back into the die of the CPU and other ICs, and thereby keeping them cooler. And from the results of my laptop testing, the temperature dropped as much as, the speed of the CPU almost doubled because of the correct cooling. The fan direction and the fan speed and how much coverage was going into the motherboard itself. So you can see where I'm coming from, right? Why do we have to cool through the package, which is a good insulator? Why don't we cool the CPU through the leads, which have direct access to the die's temperature within the packaging? So it should be much faster cooling, right? Wouldn't this be better? Wouldn't they have much faster CPUs doing it this way? What do you think? Let me know. And check out the links below. And if you love this idea, please subscribe. There are many more videos to come.